Welcome to the Deep Dive, where we give you that intellectual shortcut into complex topics. Today, we're digging into Andrej Karpathy's NanoChat project.
That's right. And our mission really is to unpack the sources and understand the thinking behind it, how he built a whole LLM pipeline start to finish.
On a tiny budget, right, that's the hook.
Exactly. The best chat GPP that $100 can buy. That's the tagline.
And it's kind of amazing because it's not just, like, the model, it's everything. Tokenization, pre-training.
Fine-tuning, checking how well it does, running it, even the web server part, all packed into this really minimal hackable code base.
So let's talk about that philosophy. Accessibility, readability. You said the code is small.
Yeah, really small, about 8,300 lines across, 44 files. It's deliberately lean.
And what's interesting is what isn't there.
Precisely. Karpathy intentionally avoided the usual suspects, these giant configuration files. Complex ways to build models, layers and layers of framework stuff.
Why? To keep it simple to understand.
Yeah, exactly. The goal was cognitive accessibility, making it so someone can actually wrap their head around the whole thing, end to end.
Makes sense. Especially since it's part of an LLM course, right? The capstone for LLM 101N?
That's right. It's designed as a strong baseline, something you can learn from directly. Optimization for the human, you could say.
Okay, so it's built for learning, and technically it runs on pretty standard high-end hardware.
A single node setup, like an 8x H100 or 8x A100 GPU box. Powerful, but accessible in the cloud.
Which brings us to the famous $100 speed run. How did that actually work?
Well, they rented one of those 8x H100 boxes, costs about $24 an hour, give or take. And the total training time, right up to the supervised fine-tuning stage, was just under 4 hours.
So 3 hours, 51 minutes times $24 an hour.
Comes out to about $92.40. So yeah, under the $100 mark.
But let's be clear, that's purely the compute cost, right? Not the human hours, the data work.
Oh, absolutely. It's just the cloud compute bill for that run. The point was showing what's possible on a tight budget with modern tools.
Got it. So where did that $92 actually go? What are the main steps?
Okay, first big chunk is pre-training. They call it the base model. That's training a 560 million parameter model.
Which is relatively small these days.
Relatively, yes. It uses about 419 FLOPs. That's a measure of computation. It trains on the FineWeb EDU dataset. This is where it learns facts like, Paris is the capital of France. Basic world knowledge.
So that builds the knowledge base, the raw intelligence, sort of.
Kind of, yeah. Then comes the next crucial phase. Mid-training and SFT, supervised fine-tuning.
And this is more about behavior.
Exactly. Teaching it the chat format, how to use special tokens for conversation, how to respond to prompts. It's like teaching it social skills.
Okay.
And, importantly, how to use tools. They teach it to use a Python interpreter, basically a calculator, to solve math problems like the GSMAK benchmark questions.
So it learns how to interact and how to use external help for specific tasks. Makes sense.
Right. It's about adapting the base knowledge for actual use.
So after all that, the $92.40 model, how good was it? What did the metrics say?
It hit a core metric score of 0.22.
And how does that stack up?
Well, for context, the core metric bundles several benchmarks, like MMLU for general knowledge questions. A score of 0.22 is just slightly better than the old GPT-2 large model, which gets around 0.21.
Okay, so better than GPT-2 large, but...
But still quite basic.
Yeah.
Karpathy himself described talking to it as a bit like talking to a kindergartner.
A very well-spoken kindergartner who knows some facts, maybe. But yeah, that score highlights the trade-offs with such a small, cheap model.
Definitely. It shows the limits you hit when you optimize heavily for cost and simplicity at that scale.
Right. Now, before we get into how scaling this up works, let's take a quick break for our sponsor. This deep dive is sponsored by embersilk.com. Embersilk is the answer for all your AI education and integration needs.
So wrapping this up, what the sources really highlight is this key parameter, depth. It basically controls the model size.
And therefore, the cost and capability.
Exactly. Karpathy points out that by just tweaking this one variable, you can scale the whole thing. You can go from this $100 kindergartner all the way up to a $1,000 tier model. That one takes about 41, 42 hours to train, and it's presumably much more capable. It shows the architecture is designed for scaling.
Which makes it a powerful learning tool.
Yeah.
You can see the direct impact of scale within the same understandable framework.
Yeah, precisely.
So here's something to think about. If accessibility, like Karpathy focused on, means reducing the cognitive load for the developer, making the code itself easier to grasp, How much performance are we leaving on the table just because our tools and code bases are too complex?
Yeah, is the bottleneck always just more GPUs, or is it sometimes just making the process more understandable, more readable?
An interesting question. Are our biggest hurdles always technical or sometimes organizational, even mental?
Food for thought.
Indeed. Well, that's all the time we have for this deep dive. If you found this useful, please do give us a 5-star review. It genuinely helps other listeners find the show.
And make sure you subscribe so you don't miss our next exploration.
Thanks for joining us. We'll see you next time on The Deep Dive.